Welcome back, viewers. Still discussing integration, and of course I've established general integration principle in the previous session, function of a function, standard integrals, and at this point in time I want us to discuss what is known as the definite integral. Alright, without much ado, we'll go straight to seeing what a definite integral looks like. Alright, now you can be asked to integrate maybe integral of x squared plus 4x minus 1 from the boundary of 2 to 1 dx. Anytime you see something like this, we call it a definite integral. So a definite integral is simply something like this. You have definite integral is something like this. Integral of f of x from b to a dx, where b is called the upper limit of a boundary and of course a is the lower limit of a boundary. So you can be asked to integrate a particular curve that is bounded by a particular region, that is from a point A to a point B. The point B is called the upper and the point A is called the lower boundary of that. You are now asked to integrate that curve. Okay, so this is what is known as the definite integral. So if I have integral of what we have on the board, x squared plus 4x minus 1, okay, dx from 2 to 1. When you solve a definite integral like this, at the end of the day, if your answer is capital F of x, okay, you were integrating f of x dx from b to a. If your answer is capital F of x, then the final solution is evaluated as f of b minus f of a. You substitute that. After you've gotten the answer by your normal integration principle, you now substitute the upper boundary into that curve minus the lower boundary. Okay, so this is equals to, now let's integrate this guy. We're going to have, this place will give us x cubed over 3. That's if you integrate x squared, you add 1 to that part, divide by that. Okay, plus the next guy is 4x squared over 2 minus, integrate this guy called 1, you are going to have x. Don't forget, integrate 1, you have x. Okay, so here is going to give us x cubed all over 3 plus 2 can cancel 4. Here we have 2x squared then minus x from 2 to 1. After we have gotten this guy, the integral, we now substitute the upper limit minus the lower limit. So our upper limit here is 2, so we now substitute it back into this answer. So we have 2 cubed is 8 all over 3 minus 2 of 2 square minus 2 minus, we now substitute 1. We put it inside the bracket so that the minus sign will open the bracket. So we now put 1 here. We have 1 cubed is 1 over 3 plus 2 times 1 square is 2 minus 1. Okay, so on the next screen we are going to have 8 minus, that place is 8 over 3 minus 2 square there is 4. Okay, so with minus 2 there will give you minus 8, then minus 2. Okay, so we are having 8 over 3 minus 8 minus 2. Okay, so on the next screen now we have 8 over 3, 8 divided by 3 minus 8 minus 2 minus into 1 over 3, that's substituting 1 now, 1 over 3 plus 2 minus 1 plus 2 minus 1. Okay, so we have plus 2 minus 1. Don't forget, when you solve a definite integral, the examiner expects you to integrate at a given boundary. So after integrating, you put the upper limit minus the lower limit. You always see it in your examination. Okay, where you've been given an integral and at the end of the day you are now given a point on top and a point below. That means it's a definite integral and you have to integrate and substitute those points. Okay, so here we are having 8 over 3 minus 8 minus 2 here will give us minus 10. Okay, minus into 1 over 3, 2 minus 1 here of course will give us 1. So we have plus 1. So this is, we can just clear everything at once. We have 8 over 3 minus 10. The negative sign opens this bracket. We have minus 1 over 3, then minus 1. So this is equals to 8 over 3 minus 1 over 3. Since both denominators are the same, we can subtract. So 8 over 3 minus 1 over 3 means 8 minus 1 is 7 all over 3. Then we have minus 10 minus 1 is minus 11. So at this point we can find LCM, which is 3. 3 into itself is 1. Yes, times this 7 on top will give us 7, okay, minus 1 into, this place is 7, okay, 1 into 3 is 3. 3 times 11 here will give us 33. Okay, so we are having 7 minus 33, and of course 7 minus 33, that's 33 minus 7, 13 minus 7, 13 minus 7, this will give you 6 here. Okay, yeah, that will give you 6 here, that's 1, so that's giving us 16. That's giving us 16, yeah, of course. So we have 7 minus 33 is minus 16 divided by 3 as the value for that definite integral. When you are given a definite integral, of course, what you do is just to integrate. After that, you substitute the upper boundary of that point you were given minus the lower boundary, and of course evaluate what you have. And just on our lecture notes, the next point is the application of integration, which is called area under the curve. What is known as area under the curve is a region that is bounded by a particular curve from a lower limit to the upper limit, which is still the definite integral I have mentioned. For instance, this is what we mean. If you have a particular curve, you have your Cartesian system, you have a curve like this, as you can see on the screen. Now at this point I have A, and at this point I have B. Okay, this is for y equals to f of x. Now the examiner wants you to find area under this curve. Area under this curve bounded by the 2 points A and B. So this guy now is called area under the curve. Area under the curve. Area under the curve. So when an examiner wants you to find area under the curve, it's going to give you that curve and the 2 points that is bounded by that curve. Okay, so you have a curve. So let's assume that, okay, maybe this curve was x squared minus 1, for instance. This curve is for x squared minus 1, and we are asked to find area under this curve when x here or a here is equals to 2 and b here is equals to 4, for instance. So that means area under the curve A is the definite integral of f of x dx from b to a. That's what it means. Which means the definite integral from 4 to 2 now, upper is now 4, lower is now 2, of the function is x squared minus 1 dx. So area under the curve is the definite integral of that curve from that point that it starts, where you are asked to evaluate the boundary to the other point. Okay, where it terminates. So this equals, if I integrate this, I have x cubed over 3, and I have integrate minus 1 here, I have minus x. From 4 to what? To 2. That's the upper boundary is 4 and the lower one is 2. So I'll now substitute 4 minus, I'll substitute 2. So if I substitute 4 here, I have 4 cubed all over 3 minus 4 minus, and now substitute 2, I'm going to have 2 cubed also all over 3 minus 2. So this equals to 4 cubed is 64 all over 3 minus 4 minus into 2 cubed is 8 all over 3 minus 2. So this equals, if I open this bracket, I have 64 minus 64 divided by 3 minus 8 all over 3. Then I have minus 4 plus 2. That's if you open that minus sign, minus 8 over 3 and minus with minus will give you plus 2. So this is going to give us 64 minus 8 is actually 56. Okay? Yeah, that's 56. That's 64 minus 8 since the numerators are the same. So that will give us 56. So we have 56 over 3. Then minus 4 plus 2 then. Minus 4 plus 2 of course is minus 2. So we have minus 2. You find LCM here, which is 3. 3 into itself is 1 times 56 is 56 minus 1 into 3 here is 3 times 2 is 6. So we are having 56 minus 6, which is 50 all over 3. So the area under this curve is 50 over 3 unit square. Unit square. That's the area. Of course, area is in square, volume is cube. You always bring it back. Alright, so after solving that area under that curve, we're having 50 divided by 3 unit square. So what you mean by area under the curve is actually the definite integral of a particular function from a particular point A, which is the lower limit, to another point, which is the upper limit B. And the simple way of evaluating it is just to integrate the function and then substitute the upper limit of that minus, of course, the lower limit. That has been our comprehensive session as far as calculus is concerned. Don't forget, I have covered differentiation very well with you, and also at this point in time I have done as much as I can, which you are expected to do when it comes to integration. This is not just what integration is all about. We still have a lot: integration by substitution, integration by parts, integration by partial fraction, integration by trigonometric substitution. But all these points are not necessary as far as this level of examination is concerned. I was just sticking to the demand of this video, and of course the examination you are preparing for. So that has been our session on calculus. You can always stick by, you can always watch our other videos, especially in mathematics. You can check out other topics which I have done and try to follow it up. Don't forget, anytime you have a question, you have a challenge, you can always drop it in the comment section, and I can guarantee you that I'll always be around to evaluate the comments, the observations, and any points you might want to raise. So we'll see you again in another session where I'll take another topic and try to help you achieve your academic dreams. See you next time. Bye.